So we have this file. So let's go and then check them out. These are tab delimited files, so we can open them using spreadsheets. So that's what we are going to do. But of course, you can also check them here. Let's just check. Let's say head, the 3 dots, reports. Yeah, it's in the KRAKEN directory. The 3 dots reports. So we see some of the files here. So that's what we are. So this is one such example for the reports. Okay, so let's proceed. Okay, so again, you can see the unclassified ones, and then we also have the classified ones here. Okay, so that's what we are. Let's also check the other files. So we see head. Let's just do it here. We see head, KRAKEN reports, lib3.kraken. That also gives us information about what we have here. Perfect. So that's what we have. So let's just proceed. Let's open it with spreadsheet software. So I'll just go and then just do that for you to see. Okay, so let's open the files. We move them to KRAKEN_report. So let's check them out. So these are the files. We will start with lib3.kraken. We will use a spreadsheet software to open both files. We are starting with this one. So let's open it. I'll open mine, so you should do same. Okay, so I have the file open. So this is how the file will appear. Now, before we explore this file, before we explore the contents, let's check the documentation that has been given on the GitHub page for KRAKEN. So let's go there. So if you are there, just scroll down and then you see this section. That is output formats. So the output formats, there are two. We are starting with the first one, which is the standard KRAKEN output format. So this particular output format, if you look at the description, it says KRAKEN 2's output lines contain 5 tab delimited fields. And so if you have 5 tab delimited fields, when we open it with a spreadsheet software, which recognizes the delimiters, we are going to have 5 columns. And with the columns, that is what we are going to look at here. So there are 5 columns. So column 1 will have either C or U. So C indicates that the sequence has been classified, and then U indicates that the sequence is unclassified. That is what it means. Now, if you look at the second column, that will contain the sequence ID. Okay, the sequence ID that was obtained from the FASTQ or the FASTQ header. And then when we look at column 3 will have the taxonomy ID that was used to label that sequence. 0 indicates that the sequence is unclassified. Take note of that. Now, if you go to column 4 has the length of the sequences. Okay, so if you are dealing with paired and reads, then you are going to have 2 values. Okay, so you have 2 values which are separated by a pipe character. That's what you should take note of. Now, with the length, it says the length of the sequence in BP. That's base pairs. So we take note of that. So for paired and reads, we are going to have 2 values, one for forward and one for reverse. They will be separated using a pipe character. Now, let's look at column 5. This is a space delimited list. It indicates the LCA mapping of each schema in the sequence. And there's an example. So let's quickly look at this example. So with the lists, this particular column, okay, we have a space delimited list. Each entry will have an ID and then the number of KMS. So that is what we see here. So let's look at this one here. So if you look at the entire thing here, from the explanation, it says that we have the first 13 KMS, which is this one, mapped to taxonomy ID 562. That's what we have here. Note that the taxonomy IDs can be looked up on the NCBI database. So the first 13 KMS mapped to this ID, and then the next 4 KMS, which is this one, mapped to taxonomy ID 561. And then the next 31 KMS, they were labeled as A. A means that the 31 kms contain an ambiguous nucleotide. That is what it means. And then the next kmer, which is 1 here, okay, this was not found in the database, and that is why it has been given the ID 0. 0 means unclassified or not found in the database. And then we have this one here, which is the last 3 kms. They were assigned to taxonomy ID 562. So this is how we interpret this particular output format. If you are dealing with paired end reads, then here we are going to have 2 entries. Okay, the entries will be separated using this. So when we have this, that means we've ended the first read, and then this one here tells us that we are starting with the second read. So we have read 1, read 2. So forward and the reverse, that is what it basically means. So the forward reads, that is my assumption by the way, the forward reads will be on the left side of this pipe character, and then the reverse reads or read 2 will be on the right side of this tab character. So that's how it is. Now let's go back and then check the files. And by the way, you can also generate some additional outputs, but then that is something we will look at later on. So let's proceed. Okay, so we have the here. So if you have opened with a spreadsheet software and you have indicated that the delimiter is a tab character, then you are going to have 5 columns. We have column 1, column 2, column 3, column 4, column 5. But if you look at this as a beginner, it's maybe difficult to understand because there are no headers to tell you what each of these columns means, or what each of these columns contains, or a header to describe the contents of each of these columns. So I have prepared another file that has headers. Okay, so I'll open that one. Okay, so this is it. So I place the status here, that is either U or C. So unclassified for U, classified for C. If you recall, after we did the classification, we had a summary. So in the summary, we realized that most of the reads were unclassified. And so it makes sense that we are seeing a lot of U's here. We have sequence name, tax ID, seq length, and then KMS. So sequence name here, taxonomy ID 0, and we have forward. Sequence length 109, 109, indicating that the forward and reverse both are 109 BP. And we have the KMS. So here the KMS, we have forward. It says the first 67 KMS are A, indicating that they contain ambiguous nucleotide. And then the next 8 KMS were unclassified. That is why we have this ID 0. So that is for the forward read. And then the reverse read, we have what? 75 KMS. 75 KMS were unclassified. That is what it means here. Okay. So that's what it is. Now let's proceed. Now, what we've done was to check one of the unclassified reads. Let's look at an example of a classified read. So I'll filter this. Let me just filter and then get the C's. I'll just do that here. Let me get those that are classified. Alright, so we have them here. And so C, that status is classified. We have the sequence name. So if you look in the FASTQ files and you search for this sequence, if you search for this name, the read that you get, the sequence that you get, that is what has been classified. So the tax ID is for cellular organisms. So this means that this read is present in cellular organisms. This is the taxonomy ID. And so here, this particular read does not give us a specific organism, does not give us a specific species, but it tells us that this belongs to cellular organisms. And we have the sequence length 150, 150 BP for both forward and reverse. And then let's look at the KMS. So we have the KMS here. This is for the forward, and then this for the reverse. That's read 2. Notice the separator here. So let's look at the forward. So it says the first 19 KMS, they had a taxonomy ID of 0. they were mapped to taxonomy ID 0, meaning they were unclassified. But then the next 5 keymes, they map to this taxonomy ID. Okay, so even though some of the keymes were unclassified, these 5 keymes were also on the read, the same read, but they were classified, and that is why that particular read was labeled as classified, despite 0 and then 0 here. So after the first 19 keymes, the next 5 keymes were mapped to this ID, and then the last 92 keymes, they were also unclassified. Okay, so that is why they have this ID 0. This is for the forward. Now let's look at the reverse. So the reverse, the first 99 keymes were unclassified. That is why they have ID of 0. And then the next 5 keymes, they were mapped to the taxonomy ID here. Okay, so you can see that we have the same ID for both forward and in the reverse. Okay, so this is for the next 5 keymes for the reverse read. And then the last 12 keymes, they were unclassified. That is what this means. Okay, so that is the interpretation, okay, of this particular file. Now let's check another one. Let's look at one which is a specific. Yeah, so let's look at this one here. I think we have one here which was let's check this one. Yeah, so we have them here. So we have another one here, and then it's classified. We have the sequence name, and then we have the taxonomy ID, and then the scientific name. I made mention. Okay, I think yeah. So I think I didn't make mention of it. So KRAKEN 2 also assigns scientific names. Okay, so this was generic cellular organism, but as we go lower, you know what classification is a hierarchy. So as we go lower and we become specific, we become more specific. The scientific names will also be assigned. And so this one, we have the name here. And so you can look up this taxonomy ID and then get more information about this organism. And then we have the information for the keymes here. We have the sequence length. There's also another one here. These reads were mapped to taxonomy ID 9606. This is for this one here. And this is for Homo sapiens. If you take a look at the information about the data on the Eugene website, you will see that the data was taken from mosquito samples. The purpose of that study was to understand the composition of the microbiome of the mosquitoes. And so what we are looking at is the microbiome of the mosquitoes. And we see that different organisms are appearing here. Now, with microbiome, you can use that to tell a story. And one of the things we can do is to establish the feeding behavior of the mosquitoes. Let's just look at Homo sapiens appearing here. This tells us that the mosquitoes probably, not all of them by the way, some of the mosquitoes probably feed on humans. Because one of the ways that we can get sequences from humans appearing here is if the mosquitoes feed on humans by taking the blood. Okay, so that is one of the things we can establish using microbiome. We can also use this study to understand the habitat, or to even identify the habitats of the mosquitoes. Okay, because some of the organisms may be found predominantly in certain locations or areas. And so if we see them appearing here, then it means that the mosquitoes probably also have their habitats in those locations or close to those locations. So, I mean, that's what it is. I am only scratching the surface here, so I believe this will help you to also analyze your own data. So let's proceed. So this is one of the files. This is file 1. Now let's look at the second file. This is the second file. That is the report. So let's open that. We are also going to open it with a spreadsheet software. Okay, so we have it open. So this is how it also appears. Let's check the description. Let's look at the description at the NCBI, at the KRAKEN GitHub page. Let's go. Okay, so this is the sample report output format. So here it says it was a tab delimited file, okay, with 1 line per taxon. And so here, if it's a tab delimited format, then we are going to have 6 columns, okay. We also specify usenames, so you have the scientific name. So we will have 6 columns. So the first column has the percentage of fragments covered by the clade, which is rooted at this taxon. And then the second column is the number of fragments covered by the clade rooted at this taxon. The third is for number of fragments assigned directly to this taxon. This and this are clades. Okay, so that's it. And then we have this, which is a rank. So with a rank, we have unclassified, we have roots, we have domain, kingdom, phylum, class, order, family, genus, species. And sometimes we can have some IDs in between these ranks. So they are given numbers. For example, if let's say we have G2, and that means G2 is somewhere between this and then this, gene and then species. Okay, and so since we have G2, that means there exists gene 1 as well. Okay, so gene 1 is what? Gene 1 has its parent as genus. So we will have genus, which may be more like a generic one, and as we are going down, we are getting closer to the species. Maybe that ID is not a complete species, but it's also not complete genus, but it's in between. So we will have these values there, G1, G2. We can also have the same for C1, C2, O1, etc. So, I mean, this is how it is. You may come across entries like this, but just get the definition here. We also have the taxonomy ID number, which is column 5, and we have the scientific name. So let's check. Now, with the KRAKEN commands, you can also add this flag, report 0 counts. Okay, so you can, depend on what you want, you can add that, but we didn't include that. So let's proceed. Let's check the sample reports file. Okay, so we are back. So we have 6 columns. 1, 2, 3, 4, 5, 6. Again, because there are no headers, it's maybe difficult trying to get information about these ones, trying to get a description for these columns. And you may not have time to always go to the GitHub page, so you can just put headers. So I have created another file that has headers, so I'll open that one. Okay, so I have that file open. So I have my reads. The first column is percentage reads for that clade, and then second column for reads, the number of reads for that clade, and then this one is for a taxon. We have rank, taxonomy ID, scientific name. The summary we got show that most of the reads were unclassified. So you can see the percentage here, 98.35. And so these ones are out. And then we also have 1.65. They were classified. Okay. And they have been labeled as roots. That's taxonomy ID 1. And then you can go there. So this is a hierarchy. So take note of that. So when you go down, it says what? We have 1.01% of the reads. We have the number of reads. They were given the rank R1. Okay, and we also have this, and we also have this. So I think this is roots. Yeah, let me just confirm. Yeah, so that is root. So here it indicates that it's somewhere in between roots and then domain. That is what this R1 here means. So it's not a root, a complete root, but it's also not a domain here, but it's in between. That is why it's R1. So we can also have R2, R3, etc. So just take note of that. And then we have cellular organisms here. So that's for the R1. Okay, so that's what we have. And then you can just use that to infer from what we have here. So this is just a brief description of the KRAKEN sample report. So if you go down, you will see the percentage of rates that were mapped to bacteria, and then you can actually go down to look at the specific ones. Now, if you take a look at this one, let's go back here, this one here. When you trace, you will see that it's Homo sapiens. The species is Homo sapiens. Okay, so that's what you're. So once you trace everything here, you'll be able to know the species that these rates were mapped to. That's what we have. So the same with bacteria. So with the bacteria, we have different species as well. I also saw virus also here. I think there were also classifications for viruses. Yeah, so this one is also. So if you look at this sample in general, we have some of the rates mapping to Homo sapiens, and some of the rates being mapped to bacteria, some of them being mapped to viruses. So I mean, there's metagenomics anyway. So we expect we will have different species of bacteria or viruses, and then also we have Homo sapiens. So I mean, we will have sequences from different organisms. That's the summary of it. And so if you know this, then you can also do some statistics. You can also do visualizations as well to try and then get a better understanding of what you have.